all incredibly happy to be here. I'm Darcy Gentleman, American Chemical Society. I'm very happy to have worked with the 10 semifinalists we brought here to San Francisco yesterday, building to this event here. We're very happy to see you here. But part of what we wanted to share with you is at ACS we like to popularize chemistry. We like to show people chemistry is fun, and it isn't just about noxious vapors that people are afraid to touch, or they mutate or something like that. And so our fantastic ACS productions team, which is at the back, giving us the live stream tonight. Woo! We wanted to show you because, they're sitting back there in the shadows and, they're kind of lurking, and they're very nice people. You should chat with them afterwards. But just to give you an idea of what they do for us, they make chemistry hot. They make chemistry tasty. They make chemistry something that you may be a little, trepidatious about trying it again, but you just can't help yourself. So they do the chemistry of something like sriracha hot sauce.
Sriracha chili sauce has become the must-have condiment for those millions of people out there who are willing to make a trade-off between a scorched tongue and the sauce's unique, spicy, garlicky flavor. Everyone who's tried it knows that it's good on everything, and by everything, we literally mean everything. But what is it about this sauce that gives it its spicy kick? The basic ingredients of sriracha are fresh ground red chilies, vinegar, garlic, salt, and sugar. Now, inside those red chilies is a group of molecules called capsaicinoids. Within this group, two molecules pack up to 95% of the blistering punch, capsaicin and dihydrocapsaicin. These two molecules trigger the TRPV1 receptor protein in our mouths, which usually responds to scalding temperatures above 109 degrees Fahrenheit, thus causing the spicy hot sensation. Then, the body responds to capsaicin's burn by releasing a pain-killing endorphin rush, kind of like the one a jogger feels after a long run. Capsaicin is naturally found in the plant genus Capsicum, which is fancy science Latin for peppers. Bell, Aleppo, Habanero, Tabasco, Cayenne, Poblano, Serrano, you name it, they're all in the capsicum genus. And although these peppers are closely related, there's a big difference between the heat of each of these peppers. So how can we use science to measure which pepper is more spicy than another? In 1912, a clever pharmacist named Wilbur Scoville devised a heat measurement scale less cleverly named the Scoville scale. This scale ranges from 0 Scoville heat units all the way up to 16 million, which is the endpoint for pure capsaicin. Basically, Scoville would extract the capsaicin out of pepper and dilute it with a solution of sugar and water until the heat was undetectable by a taste tester. Every additional dilution increases the scale. So for example, a bell pepper at 0 would not be diluted at all, while a jalapeno pepper that rests around 4,000 Scoville count would be diluted 4,000 times. This measurement scale has been criticized due to the subjective perspective of taste testers, and more modern approaches of measurement have been devised. High-performance liquid chromatography is a method of accurately measuring the concentration of capsaicinoids in a pepper. This form of spice measurement doesn't use Scoville units, but instead American Spice Trade Association pungency unit. One pungency unit is equal to about 1/15 of a Scoville unit, and are actually a parts per million count of capsaicin in a particular pepper. So then, where does sriracha fall on the Scoville scale? Depending on the crop of peppers used, sriracha can range from 1,000 to 2,500 Scoville units. To put that into perspective, Tabasco sauce runs anywhere between 2,500 and 5,000, while Texas Pete hot sauce is around 750, and a habanero pepper contains upwards to 350,000. Now that's a lot of capsaicin. Sriracha also contains two extra compounds, potassium sorbate and sodium bisulfite, that help maintain its long shelf life and vibrant red color. Potassium sorbate inhibits the growth of molds and yeast in the product and is found in other foods such as dairy products, wine, dried fruits, and meats and juices. Sodium bisulfite, on the other hand, stops the natural browning reaction that occurs when fresh produce is oxidized, giving each bottle of sriracha that lasting, highly distinguished red color. Three ingredients that greatly add to sriracha's flavor, salt, garlic, and vinegar, also act as a natural antimicrobial preservative that keep the bottle long-lasting even without refrigeration. Now, this is a really great fact to know, but it's pretty much useless because as far as we understand, it's impossible for a bottle of sriracha to go bad without having eaten it all because, again, it goes good on absolutely everything.
All right, so that, everybody, excited to taste some chemistry now? You're going to go out, all that bisulfite? Who wants to have some bisulfite now? Yeah, maybe some salt, maybe some sugar. Well, that particular video caught the taste buds of the public and got us several 100,000 views, which had, a good thing going. And we want to have more of these good things going. And so we thought, what are some other ways that chemistry can be useful? I mean, perhaps, you're not big into eating spice as much. Perhaps, you have trouble getting through life. You'd like to think of how can chemistry, how can that thing that I picked up when I was in high school that, scared me or I didn't like or whatever it may have been, is that actually useful? Well, we decided to put together a video showing you how useful chemistry can be, that you can in fact get through life more easily through the power of chemistry.
With all the evidence you need to back it up. Now let's get started. You're buying the best roast in town, but no matter what you do, your coffee always ends up bitter. Well, chances are you're brewing with water that's way too hot. The hotter the water, the deeper the extraction from your beans, and the more bitter compounds end up in your brew. So we've got an excellent trick for you so you don't have to worry about becoming a barista to get it right. If your coffee is too bitter, add a tiny little pinch of salt and taste a world of difference. When salt dissolves, sodium ions break off into your coffee and block bitter molecules from reaching your tongue, greatly enhancing the flavor. Don't have salt on hand at your neighborhood coffee shop? Just keep a couple of these in your purse or wallet and you'll do just fine. You're starving for some bananas, but all they had at the store was a bunch of bright green ones. Bananas can take a day or two to ripen, but here's a quick tip to get them up to standard really, really quick. Put your bananas in a paper bag and throw a couple ripe tomatoes in there. The bananas, depending on how green they were to start, will ripen twice as fast. This is because of a plant hormone called ethylene that's used to make fruits ripen faster. When you place ripe tomatoes into the bag with bananas, the bag traps the ethylene gas that is produced by the already ripened tomatoes, which in turn forces the bananas to ripen much faster. Also, the riper the bananas get, the more ethylene they produce. You ate way too many, way too fast, passed out on the couch and left the cookies out. Now they're rock hard, unappetizing, and spoiled your plans to spoil your own diet. No problem, here's a little trick that's been passed down for generations. Put your cookies in a tin or large Ziploc bag with a piece of bread, and they'll be soft as they were when they came out of the oven. Cookies contain far more sugars than bread. Sugars are known to be hygroscopic, that is, they soak up moisture from the surrounding environment. This, alongside the dense nature of cookies, allows them to absorb moisture coming from that piece of bread, keeping them nice and soft for a much longer period of time. So you didn't feel like doing dishes after breakfast and threw your cast iron skillet into the sink. When you get home, the thing's covered in rust and you can't bear to scrub it with a Brillo pad for a half hour. Good news for you. Open your fridge and grab that 2-liter of Coca-Cola. Coke has an ingredient called phosphoric acid that is used to add a sour punch to the super sweet soft drink. Funny thing is that this chemical is also used industrially as a rust and tarnish remover. Phosphoric acid converts your typical hard-to-clean iron oxide rust into blackish ferric phosphate that can easily be scrubbed right off. Go ahead, try it for yourself. We hope you enjoyed this first volume of Chemistry Life Hacks. There's going to be plenty more to come, and if you have any tips of your own, feel free to send them our way and we'll put them in the upcoming videos. And while you're still here, don't forget to hit that there subscribe button. Ferric phosphate that can easily be scrubbed right off. Go ahead, try it for yourself. We hope you enjoyed this first volume of Chemistry Life Hacks. There's going to be plenty more to come, and if you have any tips of your own, feel free to send them our way and we'll put them in the upcoming videos. And while you're still here, don't forget to hit that there subscribe button.
So, who here can now say that they have learned something? Okay. Now, let's see which is the most popular here. Who is glad that they can make their coffee less bitter? Okay, a few coffee drinkers. How many people are now happy to ripen their bananas at X-Men speeds? Yeah, okay, good, yeah. Who wants to save the cookies? Excellent. It's my personal favorite as well. And then something about cleaning dishes. Okay, great. Now, we're serious. Oh, okay, there. Okay, great. Now, we are serious. We said if you know of any life hacks that involve chemistry, send them in to us. We will put all the good ones into videos. We welcome that. Now, part of the reason that we're showing you this tonight is that the winner that you vote tonight is going to host one of these ACS Reactions videos, getting them potentially hundreds of thousands of views on YouTube. Now, to give you an idea of how popular these have become, we made a video a few months ago that caught the attention of the Today Show. Matt Lauer was talking about chemistry thanks to an ACS Reactions video. So the question I have for you is, what was the topic? And there's someone in the audience over there who ended up being on the Today Show as the chemistry expert thanks to this video. Now, I'll give you a hint. It wasn't hot sauce, right? Because that's a certain demographic. You don't want to necessarily in the morning. NBC is gonna lose ratings due to that, probably. Morning food. Coffee. Good idea. Things that smell nice, that make people go crazy. Bacon.
It's so delicious. Other foods are actually made better by adding bacon to it. You can even wash your body in bacon. But there's something else that makes bacon the best breakfast food out there: the smell. Throw some bacon onto the pan, and as soon as the sizzle starts, people are flocking to the kitchen. But why? Our friend over at Compound Interest, a chemistry blog, broke down the aroma science for us. It turns out there's about 150 organic compounds that contribute to the sweet smell of bacon. See, when you throw it in the pan, sugars react with the amino acids in the bacon. It's called the Maillard reaction. And it's basically what causes anything you cook, like steaks, breads, dumplings, and so on, to turn brown. For bacon, the Maillard reaction combines with the melting fats to produce the aroma compounds. What are they, you say, as you get hungrier and hungrier? About 2/3 of the compounds are hydrocarbons and aldehydes. Hydrocarbons are just hydrogen and carbon atoms chained together in thousands of different ways. Some of those chains just happen to produce a pleasant odor. Aldehydes are equally simple. They still have carbon, but they bond with oxygen as well as hydrogen, and some produce a lovely smell. But it just may be nitrogen-containing compounds that makes bacon smell like nothing else in the universe. These compounds are called pyridines and pyrazines, which put off a smell of their own. Pyridines in bacon contribute to its meaty aroma, but combine them with hydrocarbons, aldehydes, and other odor compounds, and they become the major contributor to bacony goodness. So there you have it, 150 compounds all mixing together in a pan to make bacon smell delicious. If you haven't already, hit that there subscribe button and check out some of our other videos. Maybe you like hot sauce on your bacon, maybe you are allergic to it, which would just be awful and I'm very sorry for your loss. Maybe you like hot sauce on your bacon.
So that's true. You heard it here first. Bacon smells like nothing else in the universe. Thanks to chemistry. All right. Now, who would like to see more reactions videos in general? You're going to go and view them via our website. We would like to share with you a video that we're going to put up tomorrow. So this is a sneak peek. We have not done this before. The United Nations declares it International Year of X every year. It was the International Year of the Potato a few years ago. It has been the International Year of Chemistry, as some in this room may know. Does anyone know what the science thing of the International Year of the X is this year? People who don't work for ACS. Crystallography. Absolutely. And so we have treated crystallography to ACS reactions.
When you think crystals, you probably think of flashy rocks behind glass in a natural history museum. But crystal forms are incredibly diverse and can be found in your kitchen and even inside your very own body. 2014 marks the International Year of Crystallography, so in its honor, we've put together a list of 5 crystal facts, and you'd better believe they're going to rock your world. But first, let's run through exactly what a crystal is. In short, a crystal is a uniform material with a really consistent internal molecular structure. Deep down inside a crystal, you'll see a very unique arrangement of molecules and atoms in a structure called a crystal lattice. When you think lattice, think cage. Let's start with a very famous crystal, salt. So what makes salt stand out? Well, it started the crystal craze. Father and son duo William Henry and William Lawrence Bragg wanted to know how salt formed. So in 1913, they used X-rays to figure out what crystal structures look like. For this, they won the 1915 Nobel Prize and kicked off a completely new field of science. So hats off to you, Team Bragg. But why no Nobel Prize for whoever discovered putting salt on French fries? Diamonds are tough, but there's one crystal that's even tougher. Wurtzite boron nitride is shaped very similar to diamond, except instead of carbon atoms, it's made up of boron and nitrogen. What makes it such a strong crystal is that when great stress is applied to it, the molecular bonds that keep it together have the ability to reorient themselves to relieve tension. While diamonds also do this, a boron nitride crystal ends up being about 80% stronger. If you paid attention in biology class, you learned that Watson and Crick discovered the structure of DNA in 1953. It even won them the Nobel Prize, but it might not have happened without the help of a crystallographer named Rosalind Franklin. Franklin's work in X-ray diffraction helped prove their theoretical models, leading to one of the most important scientific discoveries in the 20th century. The Crystal Cave of Mexico, deep below the Nika Mountain in the Chihuahuan Desert, is filled with some of the largest known crystal structures on Earth. Primarily made of gypsum, the same stuff used to make drywall, these crystals range up to 36 feet tall and can weigh up to 55 tons. The pink star diamond is the most expensive diamond on the planet per carat. But before we go into the astronomical numbers, you might be wondering what exactly a carat is. Well, it's simple. A carat is a unit of measurement for precious stones that equals 200 milligrams. So, 1 carat of pink star diamond is worth $1,395,761, or $6,972.81 per milligram of diamond. This shiny little rock here, yeah, it's worth over $83 million, and it's 59.6 carats in size. Crystallography has brought on an incredible scope of discoveries over the past century, so make sure to check down in the video description for a link to a list of CNEN's favorite crystal structures.
So who wants to rush out now and buy a milligram of diamond? Maybe a couple? Yeah, 3 or 4, 7. Yeah. All right. So we here at ACS, we are in the spirit of asking the public's opinion. We want to know what you would like to see for an upcoming ACS Reactions video. Perhaps the ACS Reactions video that our winner is going to host. And so we would like you all right now to vote. So pull out your smart telephonic devices. You are free to use text or Twitter. Those of you at home watching on the live stream can do this as well. You can text to 37607, that works in the US and Canada, or you can tweet from wherever on the planet you are with your happy Twitter account. So please choose donuts, atomic clocks, makeup, animals chemical communication, or jeans, using the codes on the side. And we will give you 30 seconds to vote. Yeah, okay. So I'm watching live here. We've got two things are liked. Oh no, 4 things. Okay, we have a tie. Oh, we have a leader. We have a leader, and now we have a tie. Oh, leader. 3-way tie for second. Oh, leader. Still leader. Leader. Oh, different leader. And oh, tie for first again. Oh, all right. First, we have a leader again. Still in the lead. Still in the lead. It's like watching Tour de France a little bit. All right. And I am going to stop the voting in 10, 9, 8. You can vote up to 3 times. 7, 6, 5, 4, 3, 2, 1. And the winner, with 19 votes to 14 being second place, is donuts. So ACS production guys, get working on donuts. The people want more food. All right, thank you very much. That was a little test of the voting that we're going to do later for the chemistry champions, who will also walk away with this 3D printed trophy figurine. Yes. Oh. All right. So thank you very much. We are going to just reset here quickly, and we will start the program in a minute. And now, without any further ado, we would like to start the main event for this evening, the inaugural, the 2014 Chemistry Champions Finals. Thank you all very much for coming. Thank you for watching on the live stream. And as I have said, this is going to be a popular vote contest. And I would like to, at this time, introduce you to our MC, my colleague and friend, Samora Smith.
Thank you, Darcy. I'm Samora Smith. I'm with the ACS Office of Innovation and Collaboration. I'm also the chair of the ACS Staff Council. I'm delighted and I'm very excited to be here this evening. And I would like you to show your level of excitement by giving us that great chemistry spirit. Come on, are you excited? Give it Tonight, here on this very stage, you will be given an opportunity to hear some truly amazing and compelling stories from some of the finest chemists you will ever meet. We have 5 finalists here who will share their stories with you. Get excited. Aren't you excited? But before we introduce them, we would like to congratulate and applaud all of the participants who were here last night and participated in the semifinalists competition. I'm going to invite all of our semifinalists to please come out and join me on the stage at this time. Let's applaud them as they enter the stage. Oh, come on, we could give it up for them. We have here amongst us America's finest. I'm so proud of each of you. All 10 of them came together and presented their chem stories via YouTube videos. Unfortunately, we're not able to bring them all out this evening as one of the finalists. But we're truly, truly proud of you, and we're very glad that you chose to participate in the American Chemical Society's 2014 Chemistry Champions event. You should be very proud of yourselves, and I'm hoping that each of you will decide to take your presentations even beyond tonight's event. I will now ask all of our non-competing semifinalists to please exit the stage, and while they are doing so, I would like to ask if you would continue to give them applause. Now we have our 5 finalists. We have Tian Lin. We have Alexis Schusterman. We have Jeff Dubrow. We have Jennifer Novotny. And we have Ashley Roberson. Give them all a round of applause. Wonderful young chemists. I will now ask you to exit the stage, and I will bring you back at a later time. Keep smiling, keep shining. This is a wonderful occasion that we're celebrating. The format for this evening is a very simplistic one. Each finalist will have 3 minutes to make his or her presentation, after which we will have our panel of judges who will provide 1-minute commentary and suggestions. At this time, I would like to introduce you to our panel. First, we have Lydia Franco-Hodges, theater instructor for the Alan Alda Center for Communicating Science. Let's give her a round of applause. Next, we have Sam King, author of The Disappearing Spoon and The Tales of the Dueling Neurosurgeon. Sam King, everyone. And last, we have Dr. Kiki Sanford, host of This Week in Science. Thank you. After you hear from each of our finalists this evening and receive comments from our judges, you will have the opportunity to participate by casting your vote for this year's Chemistry Champion. You will be invited to do so by texting from the US or Canada or through Twitter. There will be further procedures as to how you should cast your vote later on in this evening's program. But please pay close attention, for you will be selecting this year's winners. We will have a first runner-up. That winner will have an opportunity to host his or her own ACS webinar. That's exciting. And our grand prize winner, the first place winner, will also have an opportunity to host an ACS webinar. They will also have a chance to travel to DC, where they will tour the ACS headquarters. They will meet with other professional science communicators, and they will have an opportunity to film one of the ACS reactions video, the one of which was chosen this evening, I suppose. The winner will also have an opportunity to be the featured speaker and be listed as a chemistry expert by the National Academy of Sciences Science and Entertainment Exchange Program, a program that brings together both scientists and those of the entertainment industry. Yes, tonight's winner will have the opportunity to share his or her story with Hollywood. Get excited, get excited. Not only will we have an ACS chemistry champion, we will have our very own ACS star. So now, we can begin our program. We will start with our very first finalist. She is Jennifer Novotny. Jennifer, join me on the stage, please. Hello.
Hello.
So we meet again. It's good to see you.
It's wonderful to see you too.
Do you have a ball of nerves going on right now?
Absolutely.
Tell us a little bit about your presentation for this evening.
So tonight I'm going to share with you some of my graduate research and a little bit about a material that has changed the world.
Okay, let's start changing it. Ladies and gentlemen, Jennifer Novotny. Let's give her a round of applause.
Sorry, I'm trying to figure out the projector. Clicker is not currently clicking. Should I manually project? Excellent. Well, thanks for bearing with me.
Give it up for Jennifer for being such a great sport, Jennifer.
Yes. Yes, I can. Yes.
There you go.
Yay for problem solving. All right. Hi, I'm Jennifer Novotny, and today I'm going to share with you a material that has changed the world. I'll give you a few hints. Americans use over 60 billion pounds of it a year. It has also revolutionized the medical industry. Do you have any guesses? The answer is polymers. Polymers are large molecules made up of many smaller repeating units that we call monomers. These monomers are then chemically linked together to make the larger polymer chain. I like to think about polymers like a train, where each car represents a monomer, and then they get hooked together to make the larger polymer chain. The properties of polymers vary depending on their atomic composition and length, but you can commonly find polymers in places like plastics, vinyl, and rubber. As a scientist, I sometimes forget about how much science there really is in my daily life. So, to put it in perspective, how many of you are wearing clothes today? Good. Now, how many of you are wearing a polymer today? Everyone should have their hands up. We can thank polymers for us not being naked. Synthetic polymers, like nylon and polyester, are commonly formed into fabric fibers, but natural polymers like cotton are also used in clothing. It's really important to think about the science in the world around us. Unlike these linear train-like polymers that extend in only one dimension, the polymers I make form a three-dimensional framework similar to a jungle gym. These types of polymers are known as porous organic polymers. The polymer chains gives it shape and rigidity, but there's still a lot of free space inside. In particular, I've looked at using these polymers to detect explosives like TNT. You can envision walking into a body scanner at an airport where a device containing this polymer samples the air around you. If there are TNT molecules present, they will interact with the polymer chains, creating a visual response that we can detect. The pores of the polymer allow the TNT to interact with more of the polymer chain, creating a response that would allow TSA officials or military personnel to react to a threat more quickly. In the Dictel group, we look at using these materials to solve a variety of problems that are pressing our society today. For me, both of my brothers are in the military, so I find it particularly rewarding to know that my research could one day impact those I love. Looking at the science in our daily life, along with looking at how new technology impacts our daily life, truly shows the power of science in our world. I hope you've enjoyed learning a little bit about polymers, where you can commonly find them, and a little bit about the new research in this field. I also hope that this has given you a lens to see the world in which you see the science in your daily life. Thank you.
Wonderful. Thank you for sharing that information and letting us know that it's a great idea to not go naked and to wear polymers.
It can be quite helpful in the winter in Ithaca.
Wonderful. Now, let's hear a few words from our panel of judges. First, we'll start with Sam. What do you think?
Well, thank you, Jennifer, for going first. It was very nice. A couple things I really thought you did a very nice job of. One especially was kind of bringing it to people's daily lives, so showing them, things like clothes, the TSA scanner, how your work really affects what they're doing day to day. And I think that's very important for people trying to communicate science, because a lot of times people, kind of their eyes glaze over, they don't know what you're talking about. So I think that you did a very nice job with that. And the other thing you think you did a nice job with was starting with kind of simple things, as you said, kind of one-dimensional things, and kind of building from there. And the graphic you had about the one-dimensional building out, I thought that was kind of a good structure, a way to even think about how you're building when you're trying to communicate things, was working from one-dimensional up. So nice job on both of those things.
Wonderful. Thank you.
Lydia, care to add more?
Yes. Jennifer, I thought you had a really nice, easy confidence throughout, and I really I appreciated that you had a very polished and positive atmosphere, and that's what you projected, is positivity and also and the confidence as well. I kind of would have liked to have seen you maybe just loosen that up a little and maybe possibly breathe a little more, because I know you're nervous and I completely understand that, but maybe instead of worrying so much about, if you are worried, I'm not sure, how you sound, but really connecting to the listener. And what I really loved is about bringing in your brothers from the military and bringing in that personal piece of you, which can connect the audience to you. And I thought that was a very, very good choice. Thank you.
Great. Thank you, Lydia.
And Kiki.
I have to second the comments of the first two judges. You had wonderful poise on stage, but at the same time it was very rehearsed, and so being able to make it more casual would be just a wonderful way to bring it down and be able to connect more easily with the audience. The first question you asked the question but then rushed to your answer without waiting and giving the audience a chance to think about it. And that was your first opportunity to really connect with them. And so a little pause there would have been nicer. The second question you asked was done much better. People raised their hands, you responded, and you had a real back and forth there, which is very important. Overall, very well done. Thank you.
Great. Thank you.
Thank you to our judges. Jennifer, would you agree with any of the comments made?
No, I thought they were very wonderful comments, and I have been very nervous being up here. Fortunately, a lot with the media training we did yesterday was very helpful. I probably cut 4 or 5 sentences out of my talk to try to slow it down and give a better chance to look at the audience and try to connect with everybody. I think it is very important to look at the technology and science in our life. I think we can look at a cell phone and see the science behind it, but we don't often look at our clothing or our shoes to really see what's gone into those productions.
Well, we thank you, Jennifer. We certainly thank you for being such a great sport during the technical issue. And let's give it up again for Jennifer and Polymers. And next, our second finalist will be Ashley Robinson.
Hello.
Hi, Ashley.
How are you?
I'm doing wonderful. How are you?
I'm great.
Tell us a little bit about what you will be presenting.
Totally. So I'm from Fort Lewis College, and I research one of the largest threats to honeybee populations in the world.
Okay, so you're going to share how sweet it sounds with us.
Definitely.
Okay, well, let's get started.
All right.
Everyone, Ashley Robinson.
Hello. My name is Ashley Robinson, and I have a love affair with fruit. I love raspberries and mangoes and apples. Does anyone else enjoy eating fruit in the audience? Oh man, everyone, okay. Well, the one thing all of these fruits have in common is that they're pollinated by honeybees. And honeybees, what they have in common is the varroa mite. One of the largest parasites of the honeybee in the United States today is this small insect right here. And the way that it works is that it sucks the bee's blood, or hemolymph. And while it's not as attractive as some of the current vampires you're used to seeing, it's in essence a small vampire. Now, the reason why the varroa mite is so critical to treat is that the way that these vampires kill the varroa mites is by sucking the hemolymph, as I mentioned. But the problem is that they're just as effective at killing these mites, or killing these insects, these honeybees, as vampires are at killing humans. So if varroa mites are the problem, if they're the villain, you might say, of the story, thymol is the hero. Thymol is the essence of thyme. The same plant that you cook with every day in your own kitchen also has anti-mite properties. Now this is where the story starts. Thymol has been already in effect across the country by beekeepers. They're using it to treat their hives right now. The problem is the way that we're delivering the thymol. We're fumigating hives the same way that we fumigate termites inside houses. So in essence, on a hot day, it works really well, but on a cold day, it's almost ineffective. The other problem is that there are certain parts of the hive that are inaccessible to treatment, and this is the exact spot where varroa mites are reproducing. So we need to figure out a new way to deliver thymol to the places we need it the most at the right times. So what we're going to do at Fort Lewis College is we're going to deliver the medicine a little sweeter. So what we've done is attached a thymol molecule to a sugar molecule. Well, why do you ask? Do we have to do that? Well, thymol smells like Listerine, and bees want to eat sugar. So they're not going to voluntarily eat thymol. So we had to use synthetic organic chemistry tricks to get the job done. But once we have this molecule created, we can now feed bees this solution in a thymol sugar solution when the varroa mites are attacking. Then the two molecules break apart, the thymol becomes activated in the bee's system. Thus, wherever the bee goes, it's already immune to the varroa mites in the right place, at the right time, in every part of the hive. Proving once and for all that sugar really does make the medicine go down. Thank you very much.
Ashley, that sounds very sweet to me. Let's see how it sounds to our panel of judges. Sam, what do you think?
Very nice job, Ashley. I thought you did a very nice job connecting a lot of different things that people might not have thought to connect. So, apples and, mangoes, you usually don't think about connecting those, and then bringing thyme in and bees and wrapping all those things together. I think that's one thing that science can really do well, is make people see connections between things that they don't normally see. So I thought you did a very nice job with that. And another thing you did a nice job was with setting up a problem and making it seem, dramatic. There's this big problem, we can't deliver it. but then delivering a solution at the end. So you kind of make it dramatic, make people interested, and then make it more satisfying at the end by saying, hey, we do have a way to get at this. So I thought that was a very nice way to structure the whole thing. One thing I did notice was at the very beginning, you popped up the slide about killing vampires, and then it kind of jumped away from that. And so for a moment there, I was a little confused about where it was going, because it was going vampires to fruit or something like that. So maybe, if you had a little more time or something, just mentioning and saying, I'm going to be going this place. That's why I have this up there, and then going into it.
Totally.
Nice job. I love the fact that you started off with the love affair with fruit. That really brought me in, and I found it really engaging. I thought it was a great choice. And also, one of the first questions you asked, I felt that it was really effective, that you really asked the audience, and that you really took them in and responded to their answer. And it wasn't some pat response that was rehearsed. It was authentic and happening in you. You were really listening in that moment. Good for you. Also, I love the use of analogies and the story, how you wove it into a story with villain and hero, and the use of the vampire. I liked that very much, and I actually wanted to see that come back in again, in some capacity at the end. And I thought that you definitely did fill your purpose of how to fight the decline. Thank you.
Kiki?
Thank you so much for the work that you're doing. Honeybees are so important, first off. And for your presentation, I thought overall it was just fantastic. I think the beginning, I would have liked to have gotten a little bit more energy from you right off the bat. Totally. The love affair with fruit was wonderful, but it built, which eventually when you started talking about the actual problem you were working on, all of a sudden that's when I really started feeling your interest in it, and really I felt like I started connecting more to your story and what you were talking about, because your personal passion and interest really started coming out. So if there's a way to get that in there right in the beginning a little bit more, I think it would have been better. And then also I agree with the villain and the hero, and I think there is a little bit of massaging of the story that could be done to get the facts of what you're telling and that story out a little bit more smoothly.
Totally.
But great work. Thank you.
So Ashley, do you have any thoughts about the suggestions that have been provided? In particular, the one about the level of energy and the transitioning of your presentation?
No, totally. I really appreciate being given the chance to come up here and practice and stuff. And I really wanted to give a round of applause for these two ladies down here who gave us our training yesterday. And they really helped out a lot. And it was all thanks to them that I made it up here in the beginning. So
thanks again for being one of the finalists and presenting here this evening. Another round of applause for Ashley Robinson. How sweet the sound. Our third finalist will be Tian Lin. Hi. How are you?
Good, how are you?
Did I pronounce your name correctly that time?
You did.
Wonderful, thank you so very much. Tell me a little bit about what you will be sharing with us this evening.
So tonight I'm going to tell you a little bit about making bonds and breaking rules.
Tell me, do you break rules?
Never.
No. I guess we'll see after tonight's presentation. Everyone, let's give a round of applause for Tian Lin.
My name is Tian Lin. I studied organic chemistry, which is all about making bonds. Being an organic chemist is kind of like playing with Legos, just a really large set of Legos, where you're constantly figuring out different ways to put the pieces together. And the things that you end up making are really useful, from durable plastics to cleaner fuels to new drugs. And so that's where my research comes in. I help develop a method that connects a carbon atom to a nitrogen atom in a way that breaks one of the oldest rules in organic chemistry. It's called Markovnikov's rule, and here's what it says. When a carbon-carbon double bond reacts with an acid, this is just a molecule that's ready to give away one of its hydrogens, the double bond is going to take that hydrogen, and then nitrogen is going to add to the positive charges left behind. The nitrogen adds to the carbon with more groups attached to it because that's where the positive charge is most stabilized, and hydrogen doesn't count as a stabilizing group. You can think of it like bowling. So if you got 2 pins on one side and 1 on the other, nitrogen is the bowling ball, and you're always going to point the ball to the side with more pins. That's Markovnikov's rule. So as I've said, it's a very old rule. It's really quite powerful. In fact, you may even call it the Lord of the Rules. And so to destroy this rule, we have to go back to the literature, specifically to an inscription from the Fellowship of the Rings, which I've done my own translation of. One rule to rule them all, one rule to find them, one rule to bring them all, and in the darkness bind them. So it's that last little bit that gives us a hint to how to break the rule. We found that by adding a molecule that is activated by light, so it's called a photocatalyst, you can take just 1 electron from the double bond and form a very special intermediate. It's called a radical cation. It has a positive charge on one end, an electron on the other, and they're constantly switching places back and forth. But ultimately, nitrogen adds to the carbon that has less groups on it, so that electron can stay on the more crowded and more stable carbon. And with that, we've just broken Markovnikov's rule. So to make drugs, chemists have to make and test thousands of compounds. With our method, we've given them 1 more tool to use and 1 less rule to worry about. Thank you.
Judges, what would you like to share with us about Tian's presentation?
Oh, well, thank you again. I thought at the beginning you did a very nice job introducing yourself, kind of showing people what you do all day. I think that's a question a lot of people have about scientists. What do they do? And the analogy about building with Legos I thought would work well, just to show people what you do kind of on a basic level all day, how you spend your time. So I thought you jumped a little bit quickly into just talking about atoms, and we all of a sudden saw the diagram there. I thought maybe, maybe if you had a little more time or a little bit more space to just say, some of the atoms that are inside you, there are carbon atoms, nitrogen atoms. They're also in drugs, things like that. Just maybe give a little bit more of a transition introduction to that instead of kind of jumping right into the diagrams. And I thought you did a nice job, actually, of keeping that on a level that would engage people, not getting too in-depth in actually what was going on. But maybe just a little bit of an introduction there, I think, would have been helpful.
Thank you.
Nice job. I loved your starting with the personal. I thought that really brought us into you and wanted us to learn more about you and what you had to say. I also liked the analogy of the Legos. I thought that was very effective. And I felt, particularly in the beginning and part of the middle, you were really talking to the audience. You were really talking to people and allowing them into you. But I wanted to see you even go further with that. And I also agree with Sam about some of the transitions there needed to be more of a transition. You needed to lead us into building this suspense and then taking the time to land the next moment on us. Thank you.
Thank you.
I think that the entire presentation was really well done. Very nice pacing throughout. I don't know that I actually agree about the connection with the audience. I didn't feel as connected. I felt like you were giving a very well-rehearsed, very nice present. It was a great presentation, but I didn't feel as though it was really reaching out as much, even though within the presentation, all of the pop culture references to try and bring the audience in, I thought were just fabulously done. Lord of the Rings, you're gonna get a geek's heart with that, right? So all of that was very well done, but I think there is still a little bit more work to be done there to really connect with the audience as opposed to continue to just talk to the audience. And then additionally, I thought that the topic, the difficult technicalities of the topic, I thought you did that very well, summarized it very nicely in an easy way. I do agree with Sam that a little bit of a transition there would have been a little bit more helpful, but I liked the way that you progressed through everything in your story.
Thank you very much.
Thank you.
Thanks, Kiki. You sounded a little bit like Simon there, but we'll let you pass on that. We'll let you pass, but this is not the American Idol. It's the ACS Chemistry Champions. Let's give it up for Tian. Before you leave, you join me.
Thank you.
I want to ask you,
Yes.
what do you think about the comments you received from our judges?
I thought they were great. I really agree. And in coming here this weekend, my slides have changed and my talk has gotten better. And especially working with these ladies, they really pushed us all to the next level. And we're really trying to get there, to connect with the audience and really walk people through the sciences. That's what we're all here for. So thank you very much.
Well, I know we've all done it, so let's give a big hooray for breaking the rules, everyone. Thank you to you.
Thank you.
Now we will have our fourth finalist, Alexis Schusterman. Alexis? Hi. How are you?
I'm good.
A ball of nerves?
They're there.
You're going to be just fine. Tell us a little bit about your presentation.
Today I'll be telling you about what's going up on the roof of the Exploratorium tonight.
We don't have anything bad up there, do we?
No.
Nothing to be afraid of.
Well, we'll see.
Okay, well, let's give it up for Alexis, everyone.
We'll just check these out real quick. I like that one. Here we go. All right. We live in an era of HD. We love watching sports in HD. We like our movies in HD. Around here, even the local news is in HD. Everywhere you look, if it's not a high-definition TV, then it's a Retina display laptop or a phone that can take slow-mo video. So isn't it about time that science was in HD too? Well, my research brings the everyday benefits of HD into the realm of atmospheric chemistry. I study carbon dioxide, which you might already know is produced when you drive a car or power a factory. But when CO2 gets out into the air, it majorly alters temperatures and weather patterns and sea levels all over the world. And so for something as important as CO2, you might think that we'd have these really fancy, high-definition maps and pictures to help us keep track of it. We don't. And that's because a really nice CO2 meter is also really expensive. And so most cities can only afford to buy one. And with just one CO2 meter per city or per country, we end up with just these little blips on our CO2 map. And these little blips get smeared into these giant, messy pixels that make it really hard for researchers like me to see the patterns in CO2 that we're trying to research. For example, we can't tell if California's new climate initiative is reducing CO2 in the state. So to solve this problem, we are researching an entirely new approach. Instead of one top-of-the-line CO2 meter, we're using a bunch of these homemade sensor boxes. And we can build 12 of these boxes for the price of one fancy pants CO2 meter. And then we take these boxes and we put them on top of schools and museums all around the Bay Area. And with our boxes as little as 1 mile apart, we are making the highest definition maps of CO2 that have ever been seen. And with our maps, we can tell you where the worst CO2 is coming from, down to the individual stretch of highway. And that's not something you could even begin to see when your pixel was the size of the entire Western United States. So with our high definition data, we can start making CO2 reducing recommendations that are tailored to individual neighborhoods and institutions. With our sensors, we can even monitor who is following the newest CO2 regulations and who is breaking them. And that is exactly what it's going to take to tackle a problem as huge as global climate change. But now that we're monitoring CO2 in HD, we can give it every last pixel we've got. Thank you.
Wonderful, Alexis. Now we will hear from our judges. Sam, what do you think?
All right, well, nice job, Alexis. I thought it was very strong, even from the very beginning. Just a very good job of bringing energy, connecting it to something that people know about and care about, and from the very start, just going right after it, and so very nice job with that. And again, I thought you did a very nice job of setting up a problem and telling us why it's a problem. So we got a sense of, oh no, what are we going to do about this? And then you had the answer for it. So it's kind of satisfying when things are structured that way, where you can see the problem and then you kind of go into the solution for it. And you did a very nice job with the slides, too. I thought they really added something. Instead of just having a picture there or just kind of doing it, I thought they added something, kind of bringing something out even beyond, which I guess is good in your kind of research since you're sort of working with visual kind of things. So all those were very nice.
Thank you.
I loved it. I loved it. I thought that you stayed cool and you rolled with what was happening at the very beginning, and you took control. You took the space, and you were going to stay in charge and take us with you. So I really appreciated that. I felt you really knew your subject. I felt that your thoughts, your mind was connected to your body, and you were making the effort to connect to the audience. I kind of wanted you to stay on certain people at certain times for a longer amount so that you can land even more effectively on them. I thought your points of view were clear and vivid, and I thought you spoke with some authentic passion, and your use of sense of humor, it works for you. Careful about, it all works for me. I'm not even going to make the comment I was going to make because I don't want to mess up your head. So be well.
And Kiki.
I loved it also. Great presentation, great presence on stage from the very beginning. I loved your use of language. I thought you simplified your topic, but you didn't dumb it down too much. I think it's very appropriate for this audience, but just always be conscious of how the words you use to simplify based on the audience that you're trying to approach. I was listening to this entire presentation thinking, man, I want to see this animated as a TED Ed animation. Like, I want to see that. And I think, it really hit me, and I thought the entire presentation flowed very well. And at the end, I think you made a very large problem seem like something that we could tackle and that was solvable, and that is something that is very important for something as big as global climate change. Thank you.
Thank you. So, Alexis, do you have any further thoughts about any of the comments you've received?
Oh, those are great comments. Thank you guys so much. And thank you guys all for being here. It's really great to see support for this kind of work and for this kind of work, and all this work is so great to see support for. So thank you guys.
And thank you. Let's give another round of applause to Alexis Schusterman. Our fifth and last finalist for this evening's event will be Jeff Dubrow. How are you?
I'm good. How are you?
Doing well?
Yeah.
A little nervous?
A little bit.
You ready?
Oh, I
ready,
think
set,
I am.
Go?
Yeah.
Okay. All right. Tell us a little bit about what you will be presenting.
Yeah, I'm going to be talking about flavor and how we make a better whiskey.
I'm looking around wondering if you have any with you.
Yeah, got the flask in the back pocket.
Well, I guess we'll see. Ladies and gentlemen, right. Jeff Dubrow.
All right, so as I said, I'm going to be talking about the flavor of aged whiskey. Now, often when we eat or drink something, we don't stop and think about what makes bread taste bready or a whiskey taste like, well, whiskey. But what it all comes down to is mixtures of hundreds or even thousands of different molecules interacting with receptors in our nose and our taste buds. So, when we want to understand flavor, we first have to understand the chemistry of the foods themselves. Now, when we look at this, we really can't see anything. It's just a jumble of molecules. First, we have to break it down. We have to separate it. And we do that using a machine called a chromatograph. It takes this jumble of molecules and it separates it, letting us see what's there. We then use a machine that acts like a giant scale for tiny things, called a mass spectrometer, to whey molecules, giving us an idea of their identity. Now, all that might sound a little bit stuffy, but the applications are pretty neat. Let's take, for example, whole wheat bread. Now, one of the main consumer complaints about whole wheat bread is that it's bitter. People know it's healthy, they just don't want to eat it because it doesn't taste good. So, if we want to help people make healthy food choices, we have to help make better tasting food. Now, one of my colleagues, who's right there, has been working on this, using these tools to separate out the compounds in bread and find which ones are bitter. She then traced back the compounds and found they were formed from the oil in the bread during kneading and baking. But this approach works very well for bitterness in bread, or why a coconut smells, well, coconutty. But if we're trying to look at age in whiskey, we can't just smell age. It's almost more of a concept than a particular flavor. So instead what we do is we use our tools to get a chemical fingerprint of all the compounds that are there in a whiskey. We can then compare the fingerprints between young whiskeys and old whiskeys and see what's different. We can then take those different compounds, isolate them out, and taste them. For the ones which taste good, the ones which we like, we can find out how they're naturally formed, so we can go back to distillers and give them advice on how to tweak their processes to make better tasting whiskey. Now that's chemistry you can drink.
Thanks, Jeff. You're supposed to have enough to share, you know.
Oh, well, I just passed around.
Maybe next time. Let's hear from our judges. Sam?
Oh, thank you, Jeff. You had me at whiskey, so I was very excited about this. At the beginning, I thought you started speaking a little quickly. It seemed like you had a lot to say. You were excited about it, but you did start to speak a little quickly. Yeah. And I could understand everything you were saying, so it wasn't that it was mumbled or lost or anything. But there was kind of a difference between when you were interacting before and after and when you started actually giving the presentation. So a little more relaxed, I think. And you didn't think... I don't think what you actually did presenting the material, I think, was very well done in that you brought it back to what people know and like, talking about bread and whiskey, making a connection there. I thought all that was very good. I would have dropped a few things, especially with a popular audience. I don't think you need to mention like a mass spectrometer or maybe the instrument names necessarily. Just saying, we separated it or we did something like that. So that's just a matter of pitching it to a different audience. But overall, very well done, I think.
Thank you.
I thought it was a strong presentation, and I actually liked the use of the mass spectrometer. I liked that. I wanted to know more about it. I loved the specificity in how you use your words and your point of view about them, and really trying to land certain ideas with the audience. I feel you reaching to do that. And I do be careful, though. There's some places, in one place, for instance, the applications are pretty neat in that section there. You are kind of beginning to sound a little sing-songy. Do you know what I mean by that?
Yeah, I guess I could see that.
It's like a little sounding a little bit too rehearsed and getting into the rhythm of saying something over and over, as opposed to really, they're hearing you for the first time and you want to inspire them or infect them with this fascinating information that you have for them. So be careful about repeating that kind of sing-song voice. And your use of the audience with one of your colleagues, I love that. And at the end, take your time. Take your time with that joke. Take your time with that joke. Maybe toast the audience, and then maybe enjoy that drink.
Yeah, I agree with that. I think at the end you kind of rushed yourself to the end, and it would have been nice to just see you enjoy the fact that you got through it. The whole presentation was very well done. I think that there could have been a bit more connection with the audience, a bit less rehearsed feeling. I think that you came across very well and your use of language was good. I think, again, it depends on the audience you're trying to reach with the words that you use and also the goal that you have in what you're trying to say. And I think with your topic, you have something that's going to interest a lot of people who are into drinking fine spirits, so you have an immediate audience who are going to be interested in what you have to say. So it's titillating them and also trying to grab the people who might not drink at all. You want to, you have to remember that there are other people out there who they're not drinking at all, and you want to be able to say, okay, why is this important, and what are the really interesting aspects? So I think there's a bit of work to be done there, but overall, great.
Thank you.
I'd just like to add something. I want for you to know that rehearsal is good, but this is an audience that you have not seen yet. This is the first time they're hearing these words, so you've done the rehearsal, and trust that, and let it go. Let it go and try and reach them.
You've received some great feedback here. What do you think of some of the comments?
Yeah, I'd agree. I mean, I guess the one point of contention I'd have is in terms of adding in like the bit about the mass spec. I feel like that's such an integral part of the work that I do that it would be almost a shame to leave it out.
Yeah, and it wasn't so much that I thought you should leave it out necessarily every time. Just, depending on the audience, it's something you might want to be careful about, just something to consider. So I wouldn't necessarily say leave it out, but just something to consider.
Okay, thank you all.
Thank you, Jeff, and toast up to you as well. Wonderful. And there you have it, all 5 finalists for the American Chemical Society's Chemistry Champions Finals. Let's give it up for all of our finalists this evening. Let's also take this opportunity to give another round of applause for our wonderful panel of judges, Sam King, Lydia Franco-Hodges, and Dr. Kiki Sanford. And now, the moment you've all been waiting for, an opportunity to actually participate in this evening's finals. You may do so by texting from the United States or Canada, or via Twitter. And to hear more about the procedures for voting, I'm going to invite Darcy Gentleman back to the stage.
All right, thank you very much, Samora. Let's give it up again for our 5 finalists. Let's give it up for our 3 judges. Let's really give it up for Samora for emceeing this wonderful event. So as Samora said, this is now about you. You get to choose who the chemistry champion is. We are going to do that by text or Twitter. So you can use the number as soon as I activate it. This works from the United States and Canada, or you can use Twitter from anywhere in the world. The voting is now open. You can vote up to 3 times. And so as you can see, we have the speakers in order that they...
Robertson, Jeff Dubrow, Alexis Schusterman, and Tian Lin. Oh, we can give it up for them a little louder. I like noise. I like noise. So while the voting is being done, Mr. Gentleman. Okay, while we are troubleshooting the technical issue we're experiencing, I'm going to have a little chatter with you. Is that okay? How do you feel? Well, one thing I can surely say is that you're all champions, aren't they? I'm still very excited about everything that has been presented here this evening, and very excited about the winner. that's going to be presented as well. So, Jennifer, tell me, any lessons learned?
I thought this has been a wonderful contest, and just the preparation of getting here has been so instrumental. I think we've all learned a lot from coming here on starting yesterday morning to where we are now, and I think it's been wonderful.
Well, it's been great having you here. Ashley, what has been the most important takeaway that you can share with us this evening?
I think definitely slide content has been really interesting to learn, and how to interact with even the audience, as the judges mentioned.
Wonderful. Jeff, come on, where's the glass?
Oh, it's still high now, it's going.
Okay, we'll talk about it later. But in the meantime, share with me any further thoughts.
Further thoughts? Drink responsibly, enjoy food. Yeah, but seriously, thank you all for coming, and I hope you all learned something.
Wonderful, absolutely wonderful. Alexis, how are you?
I am well.
Tell me a little bit about what you're feeling right now.
Oh, what I'm feeling. I am feeling nervous. I do not have a smartphone or texting, so this is all on you guys. I can't tweet it or text, so it's you.
Tian.
Yes, I just want to say thanks to ACS for really investing in us, and I've met so many wonderful people this weekend who are really like-minded and really passionate about science communication.
Well, thank you. Thank you to each of you for being here and for just being such great finalists this evening. I had the opportunity of meeting each of them last night, and you did a wonderful job then, and you did an amazing job here this evening. And we can just applaud you all evening, all evening, all evening. As Darcy mentioned, this is an inaugural event, and we're hoping that from the results of this event that we will be able to perhaps carry it on maybe in the future. I want to ask each of you, have you thought about ways of taking your presentations and presenting them further beyond tonight's event? Have you thought about that at all?
So one project that this has really helped me do is start my blog, where I'm hoping to make a series of chemistry videos and a similar feeling to keep sharing chemistry to a general audience.
Wonderful. What about you, Ashley? Are you planning to do anything further?
Tomorrow at the poster session.
That's very immediate. Jeff, what about you?
Yeah, so for me, the takeaway wasn't even so much on presenting like PowerPoints. It was more just talking to people about food research, because people's first reaction when they hear about, food science is like, oh, people putting chemicals in the food. And it's kind of neat to tell people, what we do, and that it's not bad. We're trying to help people make healthy choices and make good foods taste better.
So you're trying to make our vision a reality, the vision of improving people's lives through the transforming power of chemistry. Way to go, Jeff. Way to go. Alexis, how about you? Any future plans?
My future plans aren't the mission statement of ACS, but my colleagues and I do an outreach thing in the Bay Area schools once a month, and we teach atmospheric science, clouds, and water cycle to elementary school students. So this is definitely going to be getting incorporated in all the judges' comments as well into that project for sure.
Sounds like a wonderful plan. And what about you, Tian?
Well, I've just left the lab to start a career in science communication, and I've been thinking about starting a chemistry YouTube channel, and this has been a really great experience to learn what works and what direction I might take this channel.
Thank you. It's been a wonderful experience for me to have had the opportunity to meet each of you, and I'm sure that this entire process has been a wonderful experience for you. So again, you should all be very proud. Judges, do you have any final thoughts or anything you would like to share at this time with our finals?
I just wanted to thank them again for their presentations. I thought it was a fantastic way to see, a lot of variety of research, and then to, just see so much enthusiasm. So it's very nice to see.
Thank you very much for the work you put into this. I really did enjoy your presentations, and I just encourage you to really talk to your listener rather than at them or giving your presentation. Make sure you're really trying to connect to them, and are they following you?
Thank you so much. I think all of you are wonderful communicators, and you've already shown from your the videos that you used to apply for this competition to tonight, you've already shown progress and improvement in so many areas, and I no matter what area of science communication you go into, I'm sure all of you are going to be just fabulous at it because you're obviously passionate, because you've put the time into coming here, you want to be here, and thank you for that, because we need more communicators. We need less people to stand up and dictate information. We need people to get a conversation going. And that's what you're starting to do here. So thank you very much. And I have to say, for an inaugural event, way to go. This is awesome.
Thank you again. They're still working on a resolution for the technical issue that we're experiencing with the voting. Haven't we enjoyed all of our presenters? As I stated earlier, we can applaud you all evenings. You've done such a wonderful job. Okay. You can cast your vote. You're still trying. You can do it. You can vote up to 3 times. Okay. While you're voting, I'm just going to remind you of all the wonderful prizes our winners will receive this evening. Our first runner-up will have an opportunity to host his or her own ACS webinar. And also, our grand prize winner, who will be receiving first place this evening, will also have an opportunity to host his or her own ACS webinar, as well as receive a trip to DC, where he or she will tour the ACS headquarters and meet with other professional science communicators. The first place winner will also be a featured speaker and be listed as a chemistry expert with the Science and Entertainment Exchange Program of the National Academy of Sciences. Again, one of you will have the opportunity to share your story with Hollywood. What an amazing opportunity. What an amazing opportunity. Again, you're not just ACS champions, you are ACS stars. Sam, I'm reminded that you have a little special gift for our finalists this evening. Would you like to share with them what they're going to receive from you?
An autographed copy of my first book, The Disappearing Spoon, which is sort of about the wonders of the periodic table, kind of a romp through every single element on the periodic table. So I hope you all enjoy it, and again, congratulations.
Thank you, Sam. Nicole DeFabio, member of the ACS staff, will be assisting with presenting the books. Thank you so very much. At this time, I'm also going to ask Amy Brown with the National Academy of Sciences if she would please join us. Let's give a round of applause for Amy. So very much for being here. Would you like to share with us a little bit about what the Exchange and Entertainment, about the Science and Entertainment Exchange Program?
Sure. So as you said, we are a program of the National Academy of Sciences, which I'm sure all of you have heard of. If not, it's in DC. You should go visit. Our mission is to bring together great science communicators like these folks on stage with the entertainment industry all along the way to bring better science out there, which can then, reach the public even more. I think we all know that movies, television, that sort of thing has a very far reach in this country and in this world. So it's very important, and I think we do a very good job. So thank you guys very much.
Thank you so very much. Judges, again, we appreciate the comments that you've made. It's been wonderful feedback. I'm sure that each of them will have wonderful lessons learned that they can carry back with them and will help them with polishing their presentations and allowing them to just take these presentations further and do wonderful things with them. So we appreciate you taking the time out to come and be leaders in this respect and share the feedback that you've given this evening. I'm noticing that the ladies are both wearing black and red. Did you guys plan that? Nobody thought to include me. I feel like I'm left out. But you're both very beautiful, and thank you so very much for your special gift, Sam. We have another minute. 30 seconds. 30 seconds. 30 seconds. 30 seconds. Yes, Kiki.
don't know why I didn't think of this sooner, but I would like to invite all of the finalists to come onto This Week in Science at some point within the next year. We can schedule that and talk about the science that you do. Thank you.
Okay, we're going to close the voting in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Thank you for your patience. Let me total the votes.
All right, give it up for voting, everyone. In a minute or so, we will have our ACS chemistry champion. While we're waiting for the final count, I'm glad that Kiki made the offer that she did to each of you, and it just reminded me of the conversation we had backstage when we talked about your destiny not being something known by you. Sometimes just being in the right place at the right time around the right people brings you to that destination that you're bound to reach. And this is indeed has been one of those opportunities. And I'm very, very grateful again to have had the opportunity to meet you and to also meet the judges. And thanks so very much for all the things that you've provided for our young chemists. Do we now have the results? Let's make some noise, everyone! Okay, the runner-up and winner, runner-up and winner of hosting an ACS webinar is Alexis Schusterman. Alexis, wonderful, wonderful. First place, our grand prize winner. The winner who will host an ACS webinar, travel to DC, film an ACS reaction video, meet with professional science communicators, and be listed as a chemistry expert by the National Academy of Sciences, will be Jennifer Novotny. Jennifer, you will have the opportunity of sharing your story with Hollywood! Darcy will now present you with a very beautiful Chem Champs trophy. Congratulations. How do you feel?
Really excited, and I think I'm shaking more than when I got off stage the first time.
Well, you've done an excellent job. Congratulations to you. Congratulations to all of our chemistry champions who participated in this evening's finals. And thank you to all of you for being here and bearing witness to this wonderful, wonderful event and being such wonderful supporters. You should all give yourselves a round of applause as well. Ladies and gentlemen, good evening to you all. This will now conclude the ACS Chemistry Champions Finals.